Hello again. This video is for Math 104, Trigonometry, and it's going to talk about section 3.2. In 3.2, I want to start with something that I think all of you already know, and that is the circumference of a circle equals the formula 2 pi r. Now, as you're working through this section, you should start to recognize that this 2 pi is all the way around a circle, and the circumference is all the way around the circle. So in order to start talking about something called the arc length, we're going to recognize that the circumference is the arc length of going all the way around a circle. This 2 pi is radians. So as I look around, I just made some notes. R is radius, C is circumference, and 2 pi is all the way around a circle. So when I get ready to find the formula for arc length, S equals theta r, S is going to be the arc length. So it's like an abbreviated version of the circumference. Theta is how far around the circle in radians. That's going to be an abbreviated 2 pi. So instead of going all the way around, I'm going theta around. Instead of getting the circumference, which is all the way around, I'm just getting an arc length. So if I take a look at an example, I have a chain that's wrapping around a circle. Okay, so if I say the radius, and this is an example that's in the book, is 0.8725 feet. So this radius right here is, in fact, the radius of 0.8275 feet. And let's say this theta goes 45 degrees around. Well, if you remember back to circumference, that's 2 pi. This is radians. So when I sit here and go to 40 degrees, the first thing I have to do is my conversion, multiplying it by pi over 180 degrees. The degrees cancel. I'm left with radians. 40 pi radians reduces to 2 pi radians over 9. So in order to find the arc length, I do my angle and my radius. My radius is the 0.8275. My angle measure is 2 pi over 9. And in this case, the chain will have moved 0.578 feet around the circle when I rotated 40 degrees. Now, the other piece that goes along with arc length is the area of a sector. Just like a moment ago, we had circumference equal 2 pi r for all the way around. The area is going to be the same type of formula where I have around the circle and then I use my radius to get the other part. And since it's two-dimension, that's why it becomes radius squared. Now up above, we had circumference equal 2 pi r, and we took the 2 pi out so we could put a theta in. Well, as you can see, I took this formula and I made it a 2 pi by multiplying top and bottom by 2. So in this case, I'm going to replace the 2 pi with the theta. Again, so I stay in radians. So in place of this 2 pi, I now put theta. So I have theta r squared over 2. Again, that 2 pi is going to go, and it gets replaced by theta. So that's where the formula for this area of a sector comes from. R squared times theta, or theta r squared over 2. So say I have a windshield wiper or something. I think it's a sprinkler system in the book example. And the sprinkler rotates 15 degrees, and the water shoots out 321 meters. That's a lot, 321 meters. How much of the ground is getting wet? Well, again, I need to get 15 degrees out of there, and I multiply it by pi over 180, do some reducing. I get pi over 12 radians. So 15 degrees is pi over 12 radians. Bring that over to my formula for theta. Here's my radius squared divided by 2. The area of the sector, 13,500 meters squared, or square meters. Hope that helps.